So as Francisco mentioned, I'm Jeff, I work at Puppet, and I'm going to walk through how I've used a side project to learn some of the more powerful features of Erlang, Elixir, and OTP. So I know this has to be the longest, most boring title ever, so beware, there are live demos ahead, and those never, ever go wrong. So first, a couple of caveats. I still consider myself an Elixir and Erlang beginner. I will probably tell you things that are incorrect. I'm sorry. It's definitely not intentional. This is how I feel, sort of floating around, especially with the table moving like that. I thought I understood a lot of the mechanics of how to do various aspects of Erlang and Elixir, but I didn't really feel like that I had that visceral understanding of when to use specific things and how I should use them and when to make that transition and what those trade-offs were. And for some respects, I still don't. I'm still learning. So in his excellent post on being a senior engineer, John Allspaw references sort of knowledge acquisition and skill development. And that visceral understanding that I'm talking about really shows up down here in the expert level, right? This intuitive grasp of situations. And right now, I'm still somewhere like maybe novice or advanced beginner. I needed a non-trivial project that, as it expanded, would force me to refactor and incorporate and redesign things and incorporate the things that I had learned, but not yet fully internalized, that would lead me to this intuitive grasp of the situations. So I made a thing. It's bad. I knew it would be bad, but I needed to go through that progression. And almost no books and tutorials really follow this route, save for Sasha's book, Elixir in Action, which if you haven't read, buy it. It is wonderful. It goes through the process of, here's the thing, we've reached the limits of what it can do, okay, let's improve it. So he does it much better than I can do. So I also have Erlang and Anger on my reading list, so I'll get to that eventually too. So why a chatbot? So at work we use a fork of HuBot, Kerminator. So it's a robot and a Puppet, because Puppet Labs. So just a quick show of hands of people who are vaguely familiar with HuBot. Okay, so about half. So HuBot was developed by GitHub primarily as a way of doing chat ops. So where they would have not only a public record of what had been done for automation of deployments, for bringing junior people on or new people, they could quickly see, oh, here's how we deploy to production, here's how we handle a DDoS, those sorts of things. But also as a way to force them to automate a lot of their things. So for those of you that don't know, HuBot is written in Node, and Node's execution model means that if there are any buggy extensions, it brings the whole thing down. So that's the idea. Not bringing it down, that's not the idea. But as far as chat ops, so we use HuBot internally. We tend to use it more for things like, tracking karma of like things that we like that our coworkers did, or image searches, ticket references. But we also use it some for deploying to production. But unfortunately, since the Node execution model, if there was a bug in, say, the karma module, it would prevent us from being able to deploy to production, which is awful. So that's really, to me, like when we couldn't deploy to production one day, I was like, this is what Erlang is all about, isolation of all of these processes. So I also had a coworker who had an IRC bot of his own and wanted to extend it to do like Riker quotes from Enterprise, the next generation. So I was like, wait a second, I can do that. And using Bitwalkers. So this is the second talk in a row to mention Paul Schoenfelder's work. Paul, if you're watching, thank you. He has an EXIRC library. He also did EXRM. So yeah, I developed an IRC bot. So when it all goes wrong during here, you can point and laugh, starting about now. So as we learned during Josh's talk, the network doesn't necessarily cooperate here. So I have set up hopefully it's still set up, an ad hoc network for Jeff Weiss. So you should be able to connect to it. This is the host name for the IRC server. So if you have an IRC client, please connect to it, and then you can, the channel ElixirConf, you can start sending some simple commands to OhaiBot. It should say, oh hi, as soon as you join the channel. That's how it got its name. So you can do things like Elixir++ and give it some karma. I have a Markov engine, so you can say like Markov Joe Armstrong, which was seeded with the text Joe Armstrong went to the future in the TARDIS. So there are a couple of other texts that have been run through the Markov engine. So you probably won't get Joe, if you do just Markov Joe Armstrong, you probably won't get Joe Armstrong went to the future in the TARDIS. You might get some other random string unless you actually said Markov Joe Armstrong went to the future, and then it should complete it for you. That should be unique enough. So during the talk, I'm going to talk about 3 primary things that I've used, and I will demonstrate all of these. So hope that's the plan, at least, if it cooperates. So if you're trying to connect to the network and you're having problems, let me know, and maybe we can have someone set up a hotspot. But I think it should work. We tested it right before lunch again. So supervision trees, clustering, and then the live code update. So again, none of these are specific to Elixir. But as a noob to Elixir, I was also a noob to Erlang, despite my 2 previous failed attempts with Erlang, which they failed not because of syntax or anything Erlang specific, but mostly because I didn't have a project. I didn't have something to apply it to where I would sort of go through the process that I eventually did with Elixir. So this is how I initially thought about supervision trees. So let me put the mic down here so you can hear it.
What? What do you do? Oh, don't worry, that's why I always make 2 cups of tea.
So that's the IT crowd, if you're not familiar with it. That's the perfect scene for supervisors. However, OTP actually provides a much richer framework than just that. So when I developed the app initially, it's like, oh, Elixir, Erlang, you need supervision trees. I was like, okay, great, I'll make a supervision tree. What should it look like? I was like, I don't know. I'll just stuff everything in under the single supervisor, which was great for a while. When I had a problem with the bot and it crashed, but it would usually be something originating from the client, it would cause me to reconnect. But if any of these specific pieces failed, just those would be restarted. The problem though was when the IRC client had a problem because of a flaky network connection, which was running on my laptop, close my laptop, open it again, or go from wireless access point to wired networking. All of those things would sort of cause this client process to freak out, and it would have to be restarted because the client process maintains a reference to each of the, not the brains, each of the bots, so that when a message comes in over IRC, this client process says, hey, I got a thing, do you need to do anything with it? So yeah, if just this would be restarted, these other bots wouldn't know that they needed to re-register themselves with the client process. So whatever, it's a simple IRC bot, I was running on my laptop, it was fine to restart. Eventually that got to be a pain, and I like to practice pain-driven development. So when something's a big enough pain for me to actually care about, then I automate it. So I had a few options. One, stop running an IRC bot from your laptop dummy. So that's done. I usually run it from our OpenStack infrastructure at Puppet. However, I shut it down so I could run it internally here. It usually tries to connect out to Freenode, but we actually, with the ad hoc network, don't have access out to the internet, so I'm actually also running an IRC server on one of my Vagrant VMs. So I guess I could still be running it on OpenStack there. I can restructure the supervision trees so that a death in the client process in its connection to IRC will eventually resolve itself. I could also fix the reconnect logic in EXRC, which I haven't done yet. Paul, if you're watching, I'm going to get to it eventually when it becomes a big enough pain for me. So this is what my supervision tree looks like right now. So you'll notice I'm also using something other than one-for-one. Right, so almost all of the tutorials that I went through say, like, here are the various restart strategies, but you almost always use one for one. And I was like, why would I reach for one for all or rest for one? And I didn't really have a good understanding of when I would do that. So in this case, what I did is I structured it out. I moved the brains that actually maintain some sort of state into a separate supervisor, primarily because you can't have multiple restart strategies within a single supervisor, which I learned the hard way. So particular workers you couldn't say this worker needs to be, even if that worker was a sub-supervisor, rest for one or all for one. So the brains are pulled out, and then I have a connection supervisor so that if any, sorry, I'm probably off screen now. If any of the workers from this die, it restarts them all. So the advantage that I have here is that when this client process dies from a flaky connection, what it will do, or from IRC flooding, in case the bot goes haywire, it will kill all of these bots and restart them, and when they come up, they'll re-register themselves with the client process. So which this has a reference to and passes down to the other ones. So I could have also used rest for one if I had over here, instead of having this bot supervisor, sorry, I went off camera again. So I could have obsoleted this bot, or not put it in the bot supervisor, and just had these bots also part of the connection supervisor and use rest for one, which then I would have to maintain an ordered list, and if anything prior in the list died, it would restart everything after that, which would have certainly worked well for the client process, but then if I had, say, an error in the karma bot, it would have also restarted the Markov bot, which would have been fine. The bots wouldn't like it, but it seemed a little brittle, and I would have to remember that order was important when I was specifying the workers in the supervisor. And I knew that was probably a bad idea, because I like to say that future Jeff is dumber than current Jeff. So I tried to be nice to my future self. So clustering. This is where the talk starts to get really interesting, or go wrong. I'm going to need your help. So if you're connected to the ad hoc network, I would like for you to start up a distributed Elixir session. So you can do IEX --name, your name, and then your IP address. If you use an IPv6 IP address because you don't have a self-assigned IPv4, that's fine, it'll still work. -- cookie yum. So a show of hands of people who are going to at least attempt that. Okay, so 10%-ish. Okay, and then once you're connected, I would like for you to connect to the cluster. So you can do a node connect, OhaiBot, and then this is the IP address it's a self-assigned IP address on that ad hoc network.
Wow, Chris, you should not be so trusting.
So if you didn't hear that, and certainly the recording did not, Chris's machine just said, "Wow, Chris, you should not be so trusting."
Yeah, my volume was on mute, by the way.
He was saying his computer was muted. So yeah, what I do is I'm running a node monitor. So as other machines connect to the cluster, I detect that. I read in some code, send it down to that particular node, and compile it there, and then start executing code on that machine. So in this case, I piped out through OS command to AppleScript, cranked the volume up, and then ran the say command with like wow, backtick, who am I? You should not be so trusting. Yeah. So by the way, I now have all of your SSH private keys and AWS credentials. Not true. Not true. So let's take a look at the IEX session here about what's going on. Oh no. Okay, yeah. So you'll see some things. Yeah. So some of these logger debug commands are actually originating from the people who have connected in to the cluster. However, since those processes were spawned from my machine is set up as the group leader, and so all of these debug messages come to my IEX terminal, which is incredibly helpful. So that if something's going on, oh good, we've got people connecting to the IRC channel too. So yeah, so all of the debug messages and logger messages coming to my console is incredibly useful for trying to figure out what's actually going on. And so you'll see something here about like somebody else is currently spamming. So the first person who connected, I actually don't know who it is right now. Screen had excuse me, mouse cursor, hello, there it is. Had started issuing commands to the cluster, to OhaiBot on that machine, to send me private messages. So it's now OhaiBot is sending me some messages. It's reading me some poetry from a local Krakow poet. So yeah, we'll use this to demonstrate some of the live code update stuff that I've got later. So we'll see that these messages change. So hopefully at least one person will stay connected to the channel. Okay, so let me start up the. Okay. Right. So while I begin to talk about the security model, I ran some code on your machine. It's only fair that you run some on mine. So you can do these commands. You can save the symbol for the node to a variable. It's a lot easier than trying to type it out every time. So what you can do is you can spawn some commands on my machine, and they should occur in. You should at least see the result of the Markov bot in the IRC channel. So all this does is talk directly to the brain. It's the bot that actually does the communication to, sorry, the bot portion. So there's a brain portion and a bot portion. This will just increment the state. So we give Elixir 50 more karma. And if we were to go to, oh no, oh, I need to join, nope, wrong window. I need to join the channel. I should have done that before. Add channel. Okay. So yeah, it greets me as I come in. Okay, so some people had already apparently added karma for Elixir. Now it's 103 after my initial ones. So you can see the result there of other people executing the code on my machine to modify the state, and then it eventually shows up out here. And if someone can run the Markov bot command, or should I go back to the slide so people can see what it is? Probably. This one. So if I can get somebody to run that while I'm in the IRC channel, it should show up here. Should. It doesn't necessarily need to be I say as sort of, this is what you're seeding the Markov chain with. You could just as easily seed it with Joe Armstrong. Has anybody done this? Hands up or no? Double fist shake. Okay, Chris says 1 second. So yeah, I'll go to the clustering security model slide, and then I'll come back to this. So there's the clustering security model. Okay, done. So you'll notice as you learn more about the distributed Erlang and distributed Elixir, there is no security, right? It was built during a time where it was assumed that you had full control over all of the nodes and the network in between. So as you saw from me launching code on your machines to harvest your SSH keys. So by the way, I'll be making commits as you on GitHub. That you need to be very, very cautious with the distributed Erlang, because just as easily as running things through the say command, you can do an RMRF of any node on any of the cluster, or any node in the cluster, and wipe out somebody's machine. So please don't do that. This is a very nice and accepting community and welcoming. Like, let's not do that to each other during my talk. I would feel awful. And responsible for teaching you that. What was I? There was something else I was going to say. Yeah, words. Okay. Yeah. Yeah, so it's not just Erlang and Elixir commands that you can run on other nodes in the cluster. It can also be system commands. So my crazy idea one day is to have a way to bootstrap nodes. So as soon as they connect to the cluster, they ask someone else, hey, what code should I be running? All that code is sent down to the machine, and it automatically starts running the things and cooperating. So that eventually, you don't have to set up a node ahead of time. You just connect it to the cluster, and it brings down whatever the current version of the code is in its state. So we'll see if I ever get time to actually do that. Okay, so security model, rudimentary clustering failover. So I have a spammer. I don't know who it is. Let me come back. So by spammer, I mean someone who's sending me things over here. So that would have to be a capital I. Sorry, the Markov thing is case sensitive. What was that? Oh yeah, rudimentary failover. So I have someone who is. Let me go to the IRC or IEX session. So I've got. Oh yeah, great. So whoever was spamming, it looks like it was Chris. He left, and then I elected. This is perfect timing. I elected someone else to be the spammer, and so immediately it picked it back up. And by spamming, I mean reading poetry to me and IRC. So I had an idea of like how I could do this clustering on the drive into work one day when I was scheduled to give a demo of this to my peers. The demo was scheduled for 10:30. I arrived at work around 9:15, got some coffee, thought about it, and had about 45 minutes to implement it, which I did. So that's not to say that like I'm awesome, because I'm clearly not. What is, it's the power of the ecosystem. So I don't know of any other language or runtime system that will allow you to do any sort of clustering failover like this in 45 minutes. There may be tools and frameworks that you can use, but not anything that's built directly into the language or the ecosystem. Yeah, it's amazing. So next, live code update. Okay, so I'll quickly go through some of this because Martin and Martin talked a lot about it, much more in depth than I'll go. I will demonstrate some of those things, but it really comes down to you have two situations. One where you have state that you have to worry about and migrate, and one where you don't. So if you don't have state that you care about, then you can just reload the code. So let me demonstrate that. So what, yeah, I'll leave that up. So I am somewhere in the middle of one of the poems, and if I in IRC say crash, it will crash. If I actually hit enter, there we go. It will crash the literary bot, the one that's reading it, and it restarted at the first poem. So I have an unhandled exception in that bot, and it goes up to the supervisor. It says like, oh no, I've died because I have this unhandled exception, and it restarts it. And if I go to the IEX session, you may even see. Okay, yeah. So there's the stack trace, and then it immediately restarted it. Sometimes it'll have interesting interleaving of the logger messages, and you'll see that the literary bot you get the restarting message before you actually see the stack trace, but it wasn't in this case. Okay, so yes, unhandled exception, everything is terrible. So I've got a couple of choices. I can handle the exception and then have to Torsten seppuku and go back to Java, or or I can just go ahead and get rid of the, yeah, so as you saw here, I'm raising the Ermagerd exception. So I can just get rid of that from, okay, great. Nope, here we go. And if I do an R bot literary, okay, reloaded it. And now, if I come in here, so we can see OhaiBot reading the poetry to me. If I try to crash it again, it just continues with where it was. So that code's been reloaded on the fly. It had continued sort of where it was before with the state. So, however, if I have, nope, yeah, here we go. If I have some state that I want to upgrade, again, that process that Martin and Martin talked about earlier in much greater depth is suspend the process, reload the code, run your state migration, and then resume the code. So I have some, okay, somebody left, fine. They weren't the spammer, it doesn't matter. So if I have if I have a state that I care about, then I have to migrate it. So what I'll do is, I wrote a couple sort of helper things so you didn't have to watch me type. Like if you ever want to feel insecure about how slow you type, watch Elixir Sips. It's amazing how fast Josh types. I don't know, maybe he speeds it up. That's what I tell myself, is that he speeds it up. But so I have some helper methods. So the first thing that I'll do is I'll do an upcase. So it will do its thing. And so while I actually have a sleep in there, pretending that it's going to take a while, so that we can demonstrate that. Oh, let me go back to IRC before that happens. Okay, yeah. So we saw several of them come through at once it resumed. So those messages, where's my cursor? Yeah. Those messages were queued in the process mailbox. And so immediately after it was resumed, it was able to start processing those again. And so I can demonstrate it again if I decided, oh, I'm tired of all the yelling. Let's go down case. So again, migrating, taking a while. I'll go to IRC. That death is part of the poem. It's not actually that. Okay, so yep, there we go. So the process resumed, and now everything is down case. So those are fairly simple migrations. If I wanted to do maybe a slightly more complex migration, again, not terribly more, but title case, I don't know if you've ever tried to write a title case method. It's not just simply string upcase or string downcase. I don't think there's a title case function built into string, but so title case is where every word is capitalized. So we'll go back to IRC. Let's pause, doing its thing. There we go, title case. So, yeah. So what's next? I haven't investigated ETS or DETS yet for the backend for the Markov engine. I just have an in-memory data structure, so eventually I'll take a look at that and sort of expand it out. I would like to also eventually work over the XMPP transport. I just haven't gotten to it yet. And once I do, it'll force me to redesign some of the things, so I'll abstract away some of the connection-specific stuff for IRC, so I'll probably get rid of the client process nonsense that I have in there now. I'd like to make it sort of easier to do the bot creation, so you're not so tied to, in this case, to IRC. That'll probably happen with XMPP. I'd also like to have sort of cluster distributed bots. So there's some discovery of who has the connections to whatever the underlying transport is. And I could probably implement some of this over Phoenix, which would also be interesting. But so that as you connect to the cluster, you could run a bot specifically on that cluster, and it would talk to whoever has the connection to whatever the underlying thing is, whether it's XMPP and into HipChat or IRC or something like that. So this is an unordered list. There's probably going to be other things that'll be interesting to come up. So what questions do you have? I know that was a pretty quick walkthrough. It only scratches some of the surface, but hopefully at least hearing other people around you's machines talk sort of reinforce that the clustering is powerful, yet with great power comes great responsibility. So, what questions do you have? Anyone? Chris?
So you mentioned like the topic of sending, having a node join and having a node monitor just tell it, here's all the code I want you to run. Are you aware, like that sounds really awesome, are you aware of any like current project to do that or any other guys that doing that, or is that something that, have you done any research into it?
So Chris's question was, I mentioned that I would like to have a node monitor that as things connect would send the code down to those machines and determine what they need. Am I aware of any projects that already do that, and how much have I researched it? I'm not aware of any projects that do that right now. If there's something that does that, let me know, because it's really interesting, but I haven't researched it that much. It's a crazy idea at this point. Jose?
Yeah, so what you can do is that once you're connected, you can get the bytecode files for a machine and just do an RPC call to load it to the other node. So if you want, you can just traverse other load paths and send all the code to the other machine.
Okay.
And load it there, and that's the first time for it. This is the one you start or not.
Okay, so what Jose was saying is that when you connect, you can traverse the load path of the other machine, grab all of the bytecode files, and transfer them across.
Yeah, and when we do that on IX, for example, so when you connect one machine to another machine, in order for IX to work with remote shells, we need to load the code that does the auto completion.
Okay.
We do that for example.
Okay, he's saying that's done in IEX for auto-completion when you do a remote shell. Cool. Other questions, comments? All right, thank you.